The last idea we're going to look at is how to deal with various different powers of I. Well, we remember that we set that I squared equals a negative 1. So let's kind of understand then what happens when we have I cubed. Well, I can rewrite that as I squared times I. And do you remember what I squared was? That was negative 1. Then I have the I, so then that equals a negative I. I to the fourth, same type of an idea. I can do it I squared times I squared. That equals a negative 1 times a negative 1 equals a positive 1. I to the fifth, that equals I to the fourth times I. I to the fourth we just discovered was 1 times I, just equals an I. I to the sixth, well, that can equal I to the fourth times I squared. I to the fourth was a 1. I squared is a negative 1, and that equals negative 1. I to the seventh equals any combination you want. We can do I to the fifth times I squared. I to the fifth was an I squared is a negative 1. Multiply those out, and I get negative I. Are you starting to notice a pattern, a repeating pattern? Well, we know that it begins with I equals I. So I to the first was I squared, negative 1. I cubed, negative I to the fourth, 1. Let me kind of circle those so we can see what's going on here. There's the first 4. Now the pattern repeats again. I have I, negative 1, negative I, and what do you think the next one would have been in the pattern? Yeah, you're right. It would have been 1. So if we're able to understand this pattern and use it to our benefit, then we can look at problems such as these. So if we have maybe I to the 12th, how can we reduce that? Well, I like reducing it down to a whole bunch of I to the fourths as much as I can. So if I recognize this as I to the fourth to the power of 3. Now, why did I choose to do that? Well, I to the fourth it's a 1. So this becomes 1 cubed, which equals just a 1. So our goal in this process is, with these various powers of i's, let's see how many I to the fourths we can use as factors. Let's look at I to the 39th. Well, how many I to the fourths are there? Well, I hope there's a whole bunch. It looks like there's 8, 9. Looks like there's 9 I to the fourths, because I can multiply their exponents. 4 times 9 produces a 36. And then what's left? I cubed. So I have now I to the fourth, which is a 1. 1 to the ninth times I cubed equals 1 times I cubed. And I cubed, we learned earlier, was negative I. So this equals negative I. So all of your reductions are going to reduce down to one of these first 4 opportunities here. I, negative 1, negative I, or a positive 1. One last one, then you guys can go home. How about I to the 50th? Oh, you're probably already at home. Last one, then we'll call it a day. How do we want to break that down to? Well, I'm going to try to extract all the I to the fourth factors that I can. So I have I to the fourth. How many factors of 4 go into 50? I think 12 do. And that's my highest amount. 12 times 4 is 48. Times how many i's do I have left? I squared. So then I have essentially 1, which is I to the fourth. That's the whole reason why we're doing this. I to the fourth, that's just a 1 to the 12th power times I squared. 1 to the 12th power, we love the number 1. That just becomes a 1 times an I squared. What's an I squared? I squared we set and designate as a negative 1. So I to the 50 reduces all the way down to just a negative 1. So as we're looking at different powers of I, we need to become comfortable with how many I to the fourths can we factor out. Because we want to factor out 1s. And because 1 times anything, it's just a happy 1. Anyway, Hope that helps. Have some fun.